In this video, I will discuss about the data types and variables in greater detail, right? And if you are going for job interviews, then this video is must for you. And if you are a beginner or for academics, if you are studying, then this is optional to watch this video. Now let us talk about data types. See, first of all, these are the list of data types already we have discussed in previous video. And I said that all these data types are integral type. 4 data types are there that are integral. So first question, why we have 4 data types which are integral type? Let us understand this. See, the primary data type here is integer, and integer is taking 4 bytes. If you know something about C language, you might have heard that in C language integer takes 2 bytes or 4 bytes. Maybe you have heard this 2 or 4 bytes. So here integer is taking 4 bytes. Why? On what basis it takes 4 bytes? Let us understand this. See, if we talk about the hardware or the CPU, that is processors, now presently we are using 64-bit processors. So earlier we were having 32-bit processors, and before that we used to have 16-bit processors. So what is this bit size of a processor? Bit size of a processor is, if this is a processing chip, that is microprocessor chip, and if you have seen this picture, then it will have all set of legs on this one, right? So this CPU can process upon data. So in a single shot or in a single cycle, how much size data it can process? At a time it can process 64-bit size data, large size data at a time it can process. So that's it, 64-bit. So older versions of CPUs, hardware, were capable of processing smaller size data. They were not this much capable, so they were 32-bit, and before there they were 16-bit. So this is what the bit size of machine, we say at a time how much we can process. So to understand this in simple words, let us say if I have numbers 6 and 5, if I ask you to add them, then you will quickly say this is 11. If I give you 98 and 63, and if I ask you to add them, you cannot quickly give the answer. You can give the answer for 8 and 3, that is 11, and then you take carry, then you will add it and say 161. So it will take time for you because you will do it in 2 steps. So because the numbers are 2-digit numbers. So same way, if you give a larger number to the CPU, it will take 2 steps. If it is larger than 64-bit, it will take 2 steps. And if the CPU is 32-bit, and if you are giving a larger number, then it will take 2 steps for processing upon that data. So if the capacity of a processor is less and you are giving larger data, then it has to take more than 1 CPU cycles. Means it cannot do it in 1 step. It has to do it in multiple steps, like how we did. So this is one of the concepts related to this one. Now in Java, when Java was introduced, 32-bit machines were there in the market. So therefore Java is using 4-bit for integer, right? And when C language was there, that time 2 types of machines were there. 32-bit machines were also there, 16 was also there. For 16-bit machine it used to take 2 bytes for integer, and for 32-bit machine it used to take 32-bit for integer. So here Java takes 32-bit for integer. So this becomes a basic data type for integral values or integer values, that is values without decimal. Then if you want larger value, then long is available, long, which takes 8 byte. So a 32-bit processor cannot process that long type of data in one single shot or one single step. It has to take multiple steps. Remember this one. So this means that if you are going for long, no doubt you can store larger value, but it may be slower than integer. Actually depends on the hardware. So as per the concept we discussed, we understand that long type of data type we need 2 CPU cycles. So integer can be done in 1 single CPU cycle. Now then, why we have short and byte? If you are using short and byte and the processor is 32-bit, suppose right now we are using 64, let us assume it is 32-bit, we are underutilizing a processor. We are not fully utilizing it. It is capable of processing 32-bit at a time, but we are making it do only 16-bit at a time because these are 2 bytes. 2 bytes means 16-bit. So we are underutilizing it. But the question, why Java is having that short type of data? The reason is when you declare the variable will occupy some memory, right? It will occupy some space in the memory. So that space will be less. So it is space efficient. If you are storing a smaller number, then instead of taking integer, you can take short to save some space. This is one of the reasons. Right? No doubt CPU capacity is underutilized, but the space is saved. And similarly, we have byte, so for that also space is saved. This is one reason. Then the another reason why we have short or byte is because when Java was introduced, at that time, lot of softwares which were developed in using older languages, that is, they were meant for 16-bit machines, those languages were already being used, like C or C++ or COBOL, like old languages. The softwares developed in those languages were already in use. Now, Java wanted to provide support or compatibility with those languages also, the softwares of those languages. That is the reason, another reason why Java have short as well as byte. It means if those softwares are 16-bit, then if you want Java programs to communicate with those softwares, then Java can comfortably communicate with them in 16-bit of data. This is another reason. So that's all with this. Let us quickly look at the things. See, basic data type is integer type, and it depends on the word size or the bit size of a hardware. And so Java is directly compatible with the 32-bit hardware. Then next, if you want larger size data, then long is there. And if you want backward compatibility with the old languages, then short and byte is also there. And they are also meant for saving the space. So this is about the sizes of data types. Now, next thing about them I will discuss, that is, these data types can store negative values also and positive values also, right? Negative and positive, negative and positive. So each data type supports negative and positive. So it means they are signed data type. They allow signed values, negative and positive. Let us understand how they support signed values. So I'll remove this and I will discuss. For explaining sign, I have taken an example of a byte. A byte takes 1 byte, that is 8 bits. So these are 8 bits. This is least significant bit, this is most significant bit. So in 8 bits, one of the bit is reserved as sign bit. And if that bit value is 0, then the number will be taken as positive. And if it is 1, then the number is taken as negative. So this sign bit decides whether the number contained in these bits is positive or negative. This is first thing. So a number can be stored only in 7 bits. In 7 bits, what is the minimum number that can be stored? So it can be 0, 0, 0. All these are zeros. And this is sign bit, so this is also 0. It means it is positive. So what is this value? This is 0. This is in binary form, and in decimal form it is 0. Then what is the largest value that we can have in all these 7 bits? This is 1, 1, 1, 1, 1, 1, 1. All these are ones. And this is positive, so that's why it is 0. Let us say it is positive. Then what is this equal to? This is equal to 127 in decimal form. So if you know this, then this is 1 and this is 2 power 1 and 2 power 2, 2 power 3, 2 power 4, 2 power 5 and 2 power 6. If you add all these, then it is 127. So if all 7 bits are 1, means the number is 127. And this is 0, means positive. So this is positive 127. So by keeping sign bit as 0 for positive, the smallest number is all zeros and the largest number is all ones, that is 127. Now next we will learn how a negative number is stored. So for negative number, I take an example. Suppose I want to store -5. Then this negative numbers are stored in 2's complement form. So what is this 2's complement? So first of all, let us take this 5 in positive 5. Then I will show you how it is represented in 2's complement form. So for 5, this is 1, 0, 1. And remaining 1, 2, 3, 4, 5. All these digits are zeros and these 3 digits are forming 1, 0, 1. This is positive 5 in binary form represented in 8 digits. So this value is 5. Then what is its 1's complement? First we will find out 1's complement. 1's complement means all these bits are inverted or inverse of the bits is taken. So this is 0 and this is 1 and this is 0. This is 0, so it becomes 1 and 1, 1, 1, 1. So zeros has become 1 and ones has become 0. So this is called as ones complement. Just complementing a bit makes it as a ones complement. Then in this one complement, 1 is added. So after adding 1, forget about this one, forget about this, only in this one, 1 is added. So 0 plus 1 is 1 and this 1 is as it is. Then remaining all are as it is, right? So this is 2's complement. This is 2's complement. So you should know this one. When you want to know the details, you should know how a number looks like in 2's complement. See, now this bit is 1. So this is sign bit. When it is converted into 2's complement, automatically this becomes 1. So this is sign bit. And this is 2 power 0, that is 1. And this is 2 squared, this is 2 cube. See, these are all 7 bits, right? Now this is not a positive number, it's a negative number because this bit is 1. So how to get back 5? Again, 2's complement of this number is taken to get back value 5. So this is how negative numbers are stored in the memory. I have shown you with the example of byte. Same thing applies to all these integral types. So that's all about integral types. Now next, let us move on to float and double. Let us talk about this.